I have completed the recapping of this receiver. In the process, I also replaced two resistors that were out of tolerance. One of them is right here. Let me move some of this out of the way so you can see it a little better. It's that resistor there, and I'll show you it on the schematic in a little bit. And the other one is this 3.3 meg resistor. So the next thing that we're going to be doing is rechecking the resistance values and then replacing this rotten line cord, as well as putting a fuse in the circuit. So let's check some resistances, and then we'll get started on the line cord. Because of all the changes that I've made to this chassis, not only, as I pointed out, have I replaced all the capacitors, but also a couple of resistors, this 3.3 meg and also the R4, which I can show you on a schematic perhaps a little later. But I've also been replacing wire. You notice that this is an example of a wire that was insulated from end to end until I started moving it around to try to replace the components, and it began to fall apart. Eventually, I wound up replacing a number of the yellow wires in here. You'll notice a couple here, one down there, another one over here, and this one, which runs, if I remember right, anyway, somewhere in here. I think I replaced a total of 5 or 6 yellow wires. It appears that this yellow wire that was used, and I know it probably looks brown in this video, but it actually at one time was yellow. Maybe you can tell that by looking at the very end right there. But anyway, it has browned badly. Now, I don't know if this radio has been in a corrosive environment or where it's been. It doesn't look like it, because the metal doesn't seem to have corroded that much. So I'm guessing that these wires just deteriorated because the insulation just couldn't stand up to time. But nonetheless, I replaced them. For that reason and lots of others, I'm going to redo the resistance checks on this radio before I try to power it up. Also, while I'm at it and talking about chassis and corrosion, one thing you should be careful is always wash your hands after handling any old radio. There are at least 2 sources of pollution that I'm aware of. One, of course, are animals that may have left various let's just say fluids on these chassis, particularly if they've been stored in garages or attics or barns or wherever. And second, because a lot of times the metal itself is plated with cadmium or some other material which can be hazardous. And so always wash your hands carefully after handling these. In fact, one thing, whenever I'm handling a chassis that I think might have cadmium or anything on it, I wear gloves, nitrile gloves. So, but I suggest that even if you don't wear gloves, you wash your hands after handling these chassis. Okay, let's get on and do those resistance checks. And now we've completed the resistance checks on this paper, and I filled in the new values. A few things I want to point out. One is that R4, which I mentioned earlier, the 3.3 meg AVC resistor, is now reading correctly, 3.3 meg. And you may recall that earlier this resistor was quite a bit off, and I've replaced it, and that's the resistor that I'm now measuring on the 50L6 pin 5, and you notice it now reads 468.4 ohms. It's supposed to be 470K, so that's within 1%. So I've now completed the basic resistance and capacitance measurements and replacements in this radio. The next step will be to put a power cord on it, install a reasonably sized fuse, and then we'll be ready to power it up and start checking some voltages. There are a few things in the power arrangement, that is, the way that power comes from the AC line into and through this radio, that are worthy of note. One of the issues is this network that you see right here, consisting of a 220K resistor and a 0.1 microfarad capacitor. You notice that on one end is a ground symbol, and on the other end is an earth or chassis symbol. Now, this is the chassis of the receiver. This is the V-. If you recall, the power comes in through this switch and goes to a point in the chassis that we call B-. But in this receiver, that is not the chassis. So if you measure from this B- point, or for example, this end of the power cord, which should be the neutral, and that's the way we will wire it in a little bit. What you should read is about 220,000 ohms. Now, this circuit was put in because in the early days, when the power line was connected directly to the chassis, there were a lot of bad accidents. And eventually, the radio industry began to adopt this way of isolating, not completely. There needs to be some DC path between the two. And of course, with this capacitor, there's a very low impedance for AC, especially for RF signals, through this capacitor between the chassis and B-. But this little circuit came to be known as the UL circuit from Underwriter's Laboratory. Underwriter's Laboratory, as you may know, was a safety organization established to measure the safety of electrical equipment. And eventually, UL refused to certify electronic equipment that did not have some kind of isolating circuit between the chassis and the AC line, which in this case is B-. So, in a little bit, we'll be installing a power cord here. We're also going to be putting a fuse in this circuit, and we will put the fuse in the hot side, so that if the fuse blows, then whether the power switch is on or off, there is no connection from the hot side of the AC line to anything in this chassis. While I'm at it, I'm going to mention a few other things about this particular radio. Let me slide some stuff over here to the side so we can get to that part. You'll notice over here it shows a battery connected between B- and this point, and it says 3-volt fixed bias for gain data. What they're referring to there is this line is what is called the automatic volume control, abbreviated AVC line. It is a feedback that senses how strong the audio is at the top of the volume control, filters that to remove any RF from the signal, so that it's and also to filter most of the audio, so that this point is varying with the strength of the incoming signal, and then that point is fed through the secondary of this transformer to the grid of the IF amplifier, controlling its gain, so that as the strength of the signal goes up, the gain of this stage goes down. Similarly, that point is also tied, if I can get it arranged so it's easier to see, let me zoom out just a little bit here. That point is also tied through the loop antenna and to the grid of the mixer converter, or the pentagrid converter as it's sometimes called, which is of course the first stage. So the gain of both the converter stage as well as the IF stage are controlled by this automatic volume control line. I had mentioned it earlier, and somebody in a comment said, please explain what's going on there. Now the question you might ask is, well, why are they connecting a 3-volt battery there? Well, while you're aligning the radio, or when you're trying to measure stage gain, and I'll talk about that in a second, you want this AVC line to remain constant. Sometimes it's called clamped. So if you connect a battery from this point to B minus, then this line remains at 3 volts constantly, no matter how strong the signal is. So when you're aligning a receiver, and we'll talk about that when we get there, you're interested in a couple of things. And one of the things is the actual gain of each of these stages. You want to tune the transformers so that the maximum desired signal gets through, and that's what's called alignment. Well, what you're looking for is a certain gain in each stage, and that's what all of this stuff up here is about, and we'll talk more about that when we talk about alignment. But one of the things that I did want to talk about before we get there is this note right here that says voltage is measured with respect to common minus B, and what they mean by that is this point. Then also down here, it's a little cut off because I blew this schematic up a lot. It says measured with, and what's cut off here is channelist or volt-ohmist. Now a volt-ohmist is just RCA's name for their vacuum tube voltmeters, and the channelist was a special signal tracer that was built with, see if I can get that into the shot a little better. The channelist was a special signal tracer that was originally developed by Ryder, and then the rights to manufacture it were bought by RCA. And I did a video on the channelist if you want to go look at that unit. You don't need one. They were handy pieces of equipment back in the day, but they're a little bit clumsy and bulky today. But nonetheless, for nostalgic reasons, you might want to go back and look at what a channelist did. But a volt-ohmist, the reason that I mention that is the volt-ohmist was a high impedance vacuum tube voltmeter. A modern multimeter, like the Frugal multimeter that we talked about, is equivalent to the volt-ohmist in terms of input impedance and other things. Now, it doesn't have a nice meter. And when you start doing, instead it just has a digital display, unlike the voltometer. And so when we start doing alignment, we may find that it's more convenient if we had a meter with a real scale, that is a real needle that moves around. But there are ways that we can get around that, and certainly with some careful attention to detail, we can use a digital multimeter to align this radio. But that's coming up in the future. So what I'm going to do now is tack a power cord in down here. Then I'm going to measure the current that is drawn by this receiver and insert an appropriate size fuse. Now I'm going to measure that. I already know what it should be. In the power supply rating down here, you'll notice that over in the right it says 30 watts. So we need a fuse that will handle at least 30 watts. We're going to actually put a fuse in that will handle a fair amount more than that, maybe twice that or so. But that's because that's not a very large amount of current, and we want the fuse to be large enough that it will absorb the initial turn-on current. Remember, when we turn the power on initially, all of these tubes have to heat up, and as they heat up, the power initially surges up and then begins to drop back off, and we don't want the fuse to blow before it gets to the peak of a normal operating receiver. So in the next segment, we're going to be installing a 1/2 amp fuse. Now, a 1/4 amp would handle the normal power requirements of this radio at 30 watts easily, but we want to provide for some surge current. So we'll be inserting this 1/2 amp fuse. This X indicates that we've cut that line and we've inserted a fuse in there. And I'll talk more about that in the next segment, and then we should be ready to power this radio up, see whether it works, and if it does, move on to perhaps doing some alignment. But first, one of the first things we're going to be doing after we power it up in the next segment is checking all the voltages. So I hope you'll look forward to that. Once again, I hope you enjoy the resurrection of the Frugal Repairman, and in the meantime, have a nice day.